How you can use all 38 Python operators. Arithmetic operators are for simple math calculation on numbers, including addition, subtraction, multiplication, division, floor division, modulus, and exponentiation. You use the plus for 1 plus 1, which is 2. You use the minus for 10 minus 2, which is 8. You use the star for 3 times 5, which is 50. You use 2 stars for the cube of 3, which is 27. You use the forward slash for 15 divided by 3, which is 5. You use 2 forward slashes to round down the answer for 7 divided by 2, which is 3. And you use the percentage sign to find the remainder of 10 divided by 3, which is 1. Augmented operators are for assigning values to variables and updating them. The augmented operators have similar function as arithmetic operator mentioned in the last section. Let's take addition as an example. Here, we're trying to add a value of 2 into the variable temp. We can see that by using arithmetic operator only, we need to call temp itself inside the line of code. While using augmented operator, we does not need to. Hence, augmented operator saves time when you need to do certain calculation and put the result value back to the original variable. Here are some differences between the two. Arithmetic operator can be used alone for calculation, while augmented operator is used to do calculation and then assign the value to a variable after that. Arithmetic operators can be used alone, like printing 5 plus 3, while augmented operator requires to have a variable at the left side. Comparison operators. Comparison operators are for comparing two values and give back an answer that is either true or false. They help us decide if one number is bigger, smaller, or equal to another number. You use two equal signs for 5 equals 5, which is true. You use exclamation and equal sign to check whether the left side and right side is different. In this case, which is true because 5 is not equal to 4. You use the greater sign for 5 greater than 4, which is true because 5 is greater than 4. You use the less than sign for 5 smaller than 4, which is false because 5 is greater than 4. You use the greater than and equal signs for 5 larger than or equal to 4, which is true because 5 is greater than 4. You use the less than and equal signs for 5 smaller than or equal to 4, which is false because 5 is greater than 4 and does not equal to 4. Logical operators. Logical operators are for combining multiple Boolean expressions to form compound conditions. You use AND to combine two expressions, such as 5 larger than 4 and 5 smaller than 4. 5 is greater than 4, which is true, but 5 less than 4 is false, so this AND logical expression is false. If you use OR to combine the same two expressions, 5 greater than 4 is true, but 5 smaller than 4 is false. Because one of the two expressions is true, this logical expression is still true. If you use NOT, it will negate a logical expression. 5 larger than 4 is true, thus, NOT 5 larger than 4 is false. In another example, 2 smaller than 3 is false, thus, NOT 2 smaller than 3 is true. Bitwise operators. Bitwise operators work in the binary numbers and treat each bit as a 0 or 1. The AND compares corresponding bits of two numbers. For example, the number 5 is 0101 in binary, and 3 is 0011. When we line them up, the corresponding bits are the bits right on top of each other. The smallest bits are 1 and 1. Next bits are 0 and 1. Third bits are 1 and 0. And the largest bits are 0 and 0. The AND operator looks at each pair of these corresponding bits separately to decide if both bits are 1, the result bit is 1. If either bit is 0, the result bit is 0. For 5 and 3 are the smallest bits. Both bits are 1. Thus, the resulting bit is 1. For the next bit, as one of the bits is 0, thus, the resulting bit is 0. For the third bit, as one of the bits is 0, thus the resulting bit is 0. For the largest bit, as one of the bits is 0, thus the resulting bit is 0. Together with 0001 in binary, that is 1 in denary. The result of 5 and 3 doing bitwise AND is 1. The bitwise OR returns 1 if at least one of the corresponding bits is 1. If all of the bits are 0, then the resulting bit is 0. Remember, we're looking at bits and their corresponding pairs. For 5 or 3, at the smallest bit, there are at least one of the bits is 1. That is case 1. Thus, the resulting bit is 1. For the next bit, as there's at least one 1, then that's case 1. Thus, the resulting bit is 1. For the third bit, as at least one bit is 1, that is case 1. Thus, the resulting bit is 1. For the largest bit, as all bits are 0, that is case 2. Thus, the resulting bit is 0. The result is 0, 1, 1, 1 in binary. That is 7 in denary. So, 5 or 3 gives 7. The NOT flips all bits of a single number, turning 0s to 1s and 1s to 0s. Let's say we want to calculate NOT 5. The binary of 5 is 0, 1, 0, 1. Then for each of the single bits, we flip it. 1 to 0, 0 to 1. The result is 1010 in binary, which is 10 in denary. Thus, variable equals to NOT 5 is equals to 10. The exclusive OR returns 1 when corresponding bits are different. So in the case of 5 exclusive OR 3, the binary of 5 is 0101, while the binary of 3 is 0011. The smallest corresponding bit pairs are 1 and 1. As they are the same, it is case 2. Thus, the resulting bit is 0. The next corresponding bit pairs are 0 and 1. As they are different, it is case 1. Thus, the resulting bit is 1. The next corresponding bit pairs are 1 and 0. As they are different, it is case 1. Thus, the resulting bit is 1. The next corresponding bit pairs are 0 and 0. As they are the same, it is case 2. Thus, the resulting bit is 1. 0110 is binary of 6. So, 5 exclusive OR 3 is 6. The left shift and right shift move the bits of a number to the left or right by a specified number of digits. In the left shift, like shown here, it means to left shift the bits of the binary representation of 5 by 1 bit. The binary of 5 is 0101. Then all bits are left shift by 1 bit. Then we fill up the 0. The result is 1010 in binary, which is 10 in denary. If we are aiming to right shift a 5, the binary of 5 is 0101. Then we do a right shift. The result is 0010, which is 2 in denary. Left shift operators are used to quickly multiply a number by multiples of 2. Why does left shift by 1 digit equals to multiply by 2? Recall that's a product of power, where a to the power of m times the a to the power of n is equal to a to the power of m plus n. Take these as an example. 3 to the power of 2 times 3 to the power of 1 is equal to 27, which is equal to 3 to the power of 2 plus 1, or 3 to the power of 3. In our left shift scenario, if the 1 at the smallest bit left shifts to the second digit, it is like multiplying a 2 and double the conversion for the bit 1. Right shift is similar. Left shift results in multiplying the original binary number by n times of 2, depending on number of shifts. While right shift by 1 is shifting all digits to the right by 1 digit, resulting in the original smallest bit being ignored. This bit is stating whether the binary is odd number or even number. Thus, in conclusion, if the original binary number is an odd number, 1 is ignored. A rounding action is taken. If the original binary number is an even number, this digit has a 0, and the entire even binary number will be doing division by 2. Left shift operators are used to quickly multiply by 2, while right shift operators are used to quickly divide an even number or rounding an odd number. Membership operators. Membership operators are for checking if a number or text is in a sequence like a list, tuple, or string. In this list, you can use in to check if Instagram is in a list with this code. The output is true because Instagram is in the list. You can use not in to check if YouTube is not in the list with this code. The answer is also true because YouTube isn't in the list. Identity operators. Identity operators are for checking if two variables are exactly the same object. In these two lists, if you assign A equals to matter and you use is to check if A equals to matter, you will get true because A is equal to matter. If you use is not to check if A is not equals to matter, you'll get false because A equals to matter. Operator precedence. Follow these operator precedence when coding with Python. Parentheses, exponentiation, unary plus and minus, multiplication, division, floor division and modulus, left shift and right shift, bitwise and bitwise exclusive or, bitwise or, comparison operators, identity operators, membership operators, logical not, logical and, logical or, assignment operators. In this expression, result equals to 3 plus 4 times 2 to the power of 2 minus 1 plus 2, for example. Python will first look at parentheses, then the exponentiation, then multiplication, and finally addition and subtraction. Together result 16. Now you have learned Python operators. Watch this video to learn more about Python. See you there.